Hello everybody, welcome to your Section 6 Chemtalk. I know we are not completely finished with Section 5, but with Columbus Day kind of throwing a wrench into our week, this is the best way to go with it. So nothing from this Chemtalk will be on your Section 5 quiz later this week, but we're still going to be taking the notes for Section 6 anyway. So make sure you have your green sheet out and open to Section 6. It is titled Properties of Metals and Nonmetals, and we're going to get started at the top with properties of metals. Now remember, properties mean the same thing as like a trait or a characteristic. So these are specific properties that metals will have. All right, so the first thing metals will have is luster. Right? They will look shiny or mirror-like in appearance. So you probably notice if you have a piece of metal and light is shining on it, if you move that metal, right, you can reflect the light off of it. Maybe you shined it in another sibling's eye or something like that just to be a jerk. Right? You were taking advantage of a property of metal. The second property we have here is that metals are conductors, which means that they transfer heat and electricity well. A good example of a metal conducting heat would be your frying pan. The part of your frying pan that we want to get hot is made of metal, right, so that it can conduct the heat from the stovetop through the metal to your food. But the part that we don't want to get hot, the handle, is made of nonmetals, so that you would not burn your hand when picking up your frying pan. Now, on this next slide, I have a little video that will explain how a metal can complete a circuit and conduct some electricity. It's coming. There we go. Alright, so in this video you'll see these red dots represent electrons. Now electrons have a negative charge, right? Which is why they're constantly moving around this positively charged metal. Now, in order for electricity to take place, these red electrons need to move around the circuit and flow around the circuit. Now, that will not happen until this circuit is closed. And they will be drawn to the positive side of this battery up at the top. So if we're looking at this circuit, we have a battery up the top with a positive and negative charge. We have a light source on the right, and then our metal down at the bottom. So when we close this circuit, the electrons are allowed to flow. Right? They're attracted to the positive charge of the battery. And I'm sure you've heard the term that opposites attract. Right? So a negative charge is attracted to a positive charge. Right? And they're able to be repelled by the negative charge, which shoots them along the circuit. Let me go back here for 1 second. Alright, so as these electrons are passing through the circuit, right, it allows our light to shine. And these electrons continually flow through the circuit because they freely flow through the metal. Right, if we had a non-metal here, the circuit would be stopped and they would not be allowed to flow anymore. Alright, continuing on with our properties of metals. Metals are malleable, and you should be familiar with this term from a couple sections ago, which malleable means that they're able to be hammered into thin sheets or shapes. Right? We can hit it with a hammer, and it will take that shape. It will not break. So metals are malleable. Metals are also ductile or ductile. They are able to be pulled out into a wire, which is very fortunate for us because if metals were not ductile, right, then you would not have a very loose and adaptable charger that can move around your bedroom or office freely, right? You would have to have a very thick or straight and rigid charger that would often break, right? So very nice that we have metals that are ductile. right? And they are reactive. So metals tend to react easily with other substances, whether that be acid or water or just the air around us. And some examples of metals would be Fe, which is our symbol for iron, Zn, which is our symbol for zinc, Cu, our symbol for copper, Al, our symbol for aluminum, and Mg, our symbol for magnesium. So these are all common metals. Moving on to the reactivity of metals, right? We just talked about how metals often and easily react with water and acids. Well, they will also react with the oxygen in the air, and we call this process oxidation. Right? You might have also heard of it as corrosion or as rust, but in chemistry class we will call this oxidation. So I would definitely put a star next to that term. This is something that you must know, and it will probably show up on your section 6 quiz someday. So some examples would be iron rusting, like you can see in the pictures below. And oxidation is often caused by properties such as, or oxidation often causes properties such as strength and color to deteriorate. So I'm sure you've noticed before, or you've seen in like an overgrown yard, an old car sitting there, right? And so if a force was to be applied to this car, right, it would not be as malleable, but it would also be more easily broken if something happened to it. So it has lost some strength and definitely some nice color from this chemical reaction. All right, properties of nonmetals. And we have a picture of some nonmetals here. You can see that they look a little bit different, or often can look different from metals. All right, so nonmetals often appear dull. Right? If we look at the pictures down below, we have a picture of sulfur down here to the left, and we have a picture of a red element down here on the right. Both of these, right, are pretty dull in color. They're not shiny. If I moved them side to side when we were underneath the light, it would not reflect it like a metal would. Nonmetals are non-conductors, right, or they do not transmit heat or electricity. That's why we often use nonmetals for things that we do not want to get hot, like the handle of your frying pan. Right? It's a good thing it's a non-metal, or else when you would go to hold your frying pan to either stir your food or to serve it, right, you would be burning your hand. Nonmetals are brittle, so when they are struck with a hammer, they will break, unlike metals, which we said were malleable. So brittle is the opposite of malleable. And nonmetals are non-reactive, so they don't easily react with other substances like acids or waters. It doesn't rust or oxidize like a metal would. And some examples of nonmetals would be C, which is our symbol for carbon, N, our symbol for nitrogen, O, oxygen, S, sulfur, and I, iodine. All right, now, it's not so simple as either every element on our periodic table is either a metal or a nonmetal. Sometimes we have metals that kind of have properties or characteristics of both, and we call these metalloids. Right? So metalloids are elements that act like metals in some ways and nonmetals in other ways. Right? Silicon Valley is big with using metalloids. We can take advantage of some of these properties of each, and it's very, very useful for making like new electronics or cell phones and stuff like that. And some examples of metalloids would be boron and silicon, right? Hence the name Silicon Valley. And last but not least, we have alloys. Now, alloys you would not find on your periodic table. Unlike the previous three, we can use the periodic table to find and identify metals, nonmetals, and metalloids. But alloys, right, is a solid combination of two or more metals. If you play any racing games on your video console, or maybe you're just into cars, you've probably heard of the term alloy wheels. Right? What that means is there's two different types of metals combined together, in order to make whatever wheel you have. Alloys look homogeneous, so they should look uniform throughout, even though they are made of 2 or more different metals. And some common examples of alloys would be bronze, stainless steel, steel, or chrome. Right, so chrome wheels might not always be the same as alloy wheels. So you want to make sure if you are looking for that shiny chrome wheel that you specifically order that and not just alloys, right? Because alloy might be a little bit less shiny. All right, so periodic table. I'm sure this looks familiar to you. We will be getting one out to you if we haven't already. Now you may or may not have realized that there is a little dark bolded line looking like a staircase going down the right side of your periodic table. All right, now this line is going to be important, and you will notice it on almost all periodic tables. All right, so when we are identifying, and I know the chart on your green sheet does not look exactly like this, but when we are identifying metals, nonmetals, and metalloids, we can tell by their location on the periodic table. So generally, metals are found on the left side of the staircase. So if you want to, in your diagram, right, fill in these locations. Now there will be a couple exceptions, and we're going to go over them. But metals are generally found on the left side of the periodic table and the left side of the staircase, while nonmetals will be found on the right side of the staircase. This green line, or this green section going down, right, would be along that staircase I just talked about. And elements that are along that staircase are metalloids, right? It would make sense if metalloids are or have properties of both metals and nonmetals, right? They should be located between the two. So if your element is touching the staircase, it is likely a metalloid. All right, so down at the bottom left of our periodic table is where you would find the most metallic element, and for us on the periodic table that would be francium. And up at the top right would be our most non-metallic element, and that would be fluorine. Right, so both start with an F. We have francium down at the bottom left as our most metallic, and fluorine up at the top right, or near the top right, as our most non-metallic element. All right. Now, a couple of our exceptions. So right here, right below on this green block, we have our only exception of along this staircase here. So aluminum, while it is touching the staircase, is not a metalloid. It is in fact just a metal. So make sure you're writing that in here, that aluminum is a metal and not a metalloid. Right. And up at the top left, you can notice how we have one element not connected to the metals, and that would be hydrogen. Right. So hydrogen's there because it acts like some of our metals sometimes in reactions, but it would be classified as a non-metal. So hydrogen is another one of our exceptions. It is a non-metal. All right, so that wraps up our Section 6 Chem Talk. Now remember, nothing from this video will be on your Section 5 quiz at the end of the week. Right? And so you should be watching this. It should be on Tuesday, October 13th, and we will be having our Section 5 quiz, right, unrelated to metals, nonmetals, and metalloids, the end of this week. Alrighty. So have a wonderful week of school, right? I will see you soon.